All right. Hi, everyone. Welcome to the second part of the U.S. Marine Corps Modular Logistics Challenge. This is the MLV Refine Challenge. I'm Megan Brewster, VP for Advanced Manufacturing at Launch Forth, and I'm here with Chris Blower, who is a mechanical engineer at Fathom. Fathom is our build partner for this project. They are an advanced technology-driven manufacturer of prototypes and production parts with a unique advantage of speed and agility. So today we're going to cover the winners of the MLV Design Challenge and why they were chosen. We're going to brief you on that second part, the MLV Refined Challenge that just launched, and we're going to answer any questions that you have. So as questions come up, just post them in the comment section of this feed. And to catch future videos and broadcasts like this one, just make sure to like the Launch Forth Facebook page.
So, the second MLV challenge is now open and available on the Launch Forth website. We have been coordinating with the US Marine Corps over the last project to bring to you a series of objectives and requirements to complete the first challenge. Now, we work closely with the US Marine Corps to get the needs for their MLV so that we can give you the best opportunity available. Now, with the second challenge, with the first challenge, we worked here at Fathom with Launch Forth as a set of advisors to give guidance to the vehicle's design and opportunities so we can make it as manufacturable as possible as we go forward. With this, there was 5 key categories that were defined and required by the US Marine Corps. That was, it was hackable, modular, high capacity, easy to use, and functional. With these were the characteristics that we looked at when we were doing when Launch Forth was doing the judging for this competition. Now, what we're going to do is we're going to go have a look through all of the winners and point out the key factors that made them the best, essentially.
So first place is the Slog by Vasilados Yanis.
So this vehicle was truly amazing and rightfully the first winner because of the innovative designs that he contributed. Now, this vehicle has electric motors on each of the 6 wheels, has the ability to do tight turning radii because of the dual turning axis, and has a linkage mechanism between each of the modules so it can cover adverse terrain and can be easily changed out for different modules. So you can have a cargo section and then a personnel section combined together, and they can be easily swapped out as the project goes forwards or as you need according to your operations on base. So as you can see here, he went into a lot of depth presenting the battery the options for battery locations, the tire types that we wanted. It was very well thought out and very impressive.
And what I liked about this submission is that Yanis put a lot of thought into the manufacturability of this vehicle, which is going to be really important to the Marines. Second place is the Voynich by Gabi Hansen.
Now, this model was equally as impressive, in my opinion. The rear section of the vehicle Has a modular trunk to it, essentially, where each of the modules can be hand lifted on and off the back of the vehicle. Now, we can have it set up so that it can be similar to that of a traditional truck where you have a flatbed, or it can be mounted with seats, or the wood or mechanical shops can be located in these predefined modules so you can then interchange them very easily and efficiently. Very impressive.
Yeah, what I liked about this is that the T-shaped chassis really makes use of maximum space, and it allows for easy sliding on and off of the modules. So it'll be very easy for the Marines to change out those modules in the field.
Yeah, every inch of the defined volume was used with this vehicle, which was what the Marines are all about, making the best of everything.
Great. And now on to the judges' favorites. So the first one that we'll highlight is the Ugly Mule, submitted by Brett.
Now, this vehicle was truly impressive for its ingenuity with regards to the mechanisms that were installed on board. Now, this was a favorite because of the actual modularity and the thought that went into this. As you can see, he has gone through different designs on how to make them interconnectable, so you can have trains or trailer mechanisms so that you can then carry more than what is necessary. the vehicles can have different connectors and linkages, so you can then easily slide on and slide off their respective modules again. So very well thought out, and driving forwards the one of the key objectives of making it modular, easy to use, and functional. So really good.
And one of the things I love about this design, in addition to the seats facing out, because as you remember, Marines are people too, so that'll be much more comfortable for them, is that Brett included a storyline of the revisions that he went through, and that leaves a very robust digital thread of the co-creation process. So the next one we'll highlight is the Packhorse 3D submitted by Christian F.
So this unit was truly phenomenal to see, and to see their ideas come to life. Primarily because the tub design on the actual base of the vehicle was proposed to be completely 3D printed. And he actually discussed and presented the fact that you'd print it on its side, and it would be then the most effective and efficient way to print with use of material. And from there was able to employ different additive technologies to be able to make this vehicle as effective and easy to repair and work with on site and wherever the vehicle is located.
Yeah, as Chris mentioned, Christian's put a lot of effort into the design for additive manufacturing, which we really appreciate. It helps us more rapidly prototype and manufacture this vehicle. The next one is the LEMV submitted by Tom Sazanoff.
So this vehicle again uses a tub design. It is it's electric propulsion system. Allows it to be very lightweight, very compact, so you can make the maximum use of the volume available. The other aspect of it that was really popular amongst the launch 4 team was the modularity with regards to the structure. Now, each of the joints that are connected in has the ability to be changed and adjusted so that you can carry different cargo, different equipment, different personnel. And it was the fact that the actual linkages had been had so much review and assessment put into it, which was really inspiring to see.
Yeah, I agree. The very simple rail design allows for layered complexity on top of it. The next submission is the Universal Basic Vehicle, which was submitted by Brennan Metcalf.
So this vehicle was, in my opinion, inspired by like the 1940s Land Rovers. This vehicle has been seen throughout time, especially with the military, as being very effective and reliable. And the use of having multiple flat surfaces allows it to be easy to carry cargo and other materials, to be able to read your maps on the front, on the hood of it, etc. So very effective in that aspect. The additional benefit to it as well is that with it all being with use of flat material, if you do need to have spare parts, they are easily stackable and easily transportable versus the modern day bumpers and hoods that are very complex geometries and take up a lot of space when moving from point A to point B.
Exactly. And similar to the LMV, this uses a very simple snap together process so that it's easy to assemble, but the possibilities are endless. The final selection by the judges was the Modus Mlv submitted by Lulu.
So this vehicle was very inspiring again because of the use of the full volume that was predefined. Now this vehicle uses every possible cubic inch, which is really good. The design is following a tubular chassis, which allows different materials and different cargoes to be installed within the unit. Allowing you to put the personnel or the cargo in, and it does. This design is autonomous, so it is a case of that it doesn't have the requirement for the driver's seat to be located at the front of the vehicle, and all of the powertrain is located underneath. So it does give you that uninterrupted, unobstructed volume to be actually able to work with.
And it's great that every station is configurable, so each Marine can kind of set that up the way that they want.
The additional component, which I'll add there, is also the cylindrical chassis that we have on the base as well. That is a very innovative and new idea that was very unique to the competition that we've seen here as well. So, okay, so the next stage of the process is that we are going to take all of these winning designs and we're going to actually print them out to make 1/15th scale models that we're going to send out to the US Marines so they can see the innovative designs that the community, Launch 4 community has come up with. They're very excited with the designs already, but they're even more excited to get them in their hands as well. Now, with regards to this, we are now moving into the second stage of the competition, the Refine Challenge. It's currently open, and we are now we now want you to take inspiration from the concepts and make it into a reality. So with this level of the competition, we want you to take the key fundamental ideas that you've seen with regards to these competition winners and pick out the functionality, the modularity, and be able to refine those into your own concept. Now, one of the things we want to point out, this is not a blue sky challenge. We want you to be able to take these ideas and then to be able to build from them. Don't worry about building from scratch. We're giving you these designs as points that the Marines have said that, and Launch Force have said that they are really passionate about and find very viable. So work from those. That's a key component as well.
That's perfect. And in addition, just don't forget the design principles. So they're the same 5 design principles from the previous challenge. So those are modular, hackable, easy to use, functional, and high capacity. And we've added one new design principle, and that is future forward, which we're going to talk about in a minute. In terms of timeline, as Chris mentioned, we're accepting submissions already from now through April 8th. Then there will be a validation period for your submissions from April 9th through the 22nd, and we're going to look to announce the winners around May 1st. So because this challenge is quite technical and it's going to require a range of skills from design to engineering, we're strongly encouraging that you team up for this challenge. So here are 2 steps that you can take right now to form a team. So the first is to post a description of the skills that you have or the skills that you're looking for as you design a team. So you can do this by navigating to the MLV challenge, Refine Challenge page, then looking for the Discuss tab. And under that, you'll see a discussion thread called Teams. So you can make your post there. Some skill sets to get you started include concept, illustration, technical and engineering, research, and communication or organization. A second step that you can take right now to form a team is submit an early entry. So when you do this, as you're filling out the entry form, you've probably noticed that you can insert teammates in that entry form. When you do that, it unlocks a private discussion thread for the teammates that you've listed. So this is a way for you guys to connect privately, also share your contact information privately if you want to take the conversation offline. In addition, when you submit an early entry, this allows you to get feedback from the community, which is, what we're here for, co-creation at its finest.
So with regards to the next stage of the process, what we want you to do is we want you to submit all of your necessary CAD files, as we need to be able to assess them for manufacturability and to be able to do the necessary adjustments so that we can build them either by additive, subtractive, or hybridized manufacturing. With this, we want you to be able to we want you to send us the CAD files in their neutral format and then also in their native. That is the key 2 components for us to be able to use them and to be able to move forwards with this competition. Now, please note that we will be using each of these designs and reviewing them as the competition goes along. So if you want any feedback, we can certainly give that as well.
Great. And make sure to use, under the ignition kit, there's a PDF checklist that you can use to keep all the files straight, because we are requiring a lot. In addition to the full assembly, we're also looking for each of the modules shown in their use case scenario. So there's quite a few files that we're asking for. So use that checklist to make sure that your submission is complete. And as a reminder, the use cases are personnel, construction, mechanical, and administrative. Each of these use cases have a specific number of personnel that need to be carried, the packs, the equipment that is needed, and all of that information is in the challenge brief. So as we mentioned, there's a new design principle and it's future forward. So in this case, we are asking you to include additive manufacturing in your submission. And the reason why is because more than a vehicle, the Marines are looking for a rapid innovation system that allows them to go from concept to prototype to manufacture faster than ever before. And one of the technologies that can keep up is additive. So we're asking you to help us identify which parts of the vehicle make sense for this advanced manufacturing technology. So for example, if it's a part that fails often, or it's hard to get a replacement when you're in the field, it takes a long time to get a replacement, Or if you're trying to reduce the weight of the vehicle, so you want to generatively design one of your parts, then it's not going to be easy to make that by traditional manufacturing methods.
And that's one of the key components where Fathom actually comes in as well. Because we specialize in additive manufacturing, we've got a lot of insight in how we can help with the development of this vehicle through the use of additive manufacturing. For a key couple of examples, one of the things that we have got to demonstrate here is, for argument's sake, the brake mechanic leverage component. This unit is traditionally made out of steel or aluminium, but in this case, we have built it out of carbon-filled nylon. Now, this is 65% lighter than a traditional component. It is just as stiff and just as strong. And the brilliant thing is that with components like this, we don't need to carry multiple of them around or have them in inventory if we can additively manufacture. All we need is the raw material that we can then build up and actually generate the component versus having that unnecessary inventory. One of the other aspects as well is that with Fathom, we're actually a technology neutral company. One of those is that our partner is Stratasys, which is an FDM printing company. Now, they partnered up with Jay Leno's shop or garage to be able to repair some of his previous vehicles where components were not existent or not available for the unique collections that he had. One of them being a 1970s Ford Cosworth Racer, and it's a case of that one of the units wasn't available, so we were able to they were able to scan the unit, be able to print it off, and then subsequently we were able to make casts that could then be repeated to actually make an exact replica of the component, thereby allowing these unique components to be built using additive manufacturing in a new and unique way. So
that's great. So traditional manufacturing method, casting, but using digital manufacturing principles and additive machines. So now we're going to take your questions. So if you have questions, again, just post them to the comment section of this broadcast, and I'm going to read some of them right now. So Yasser Iftikhar is wondering, what areas should we focus on? So in this challenge, just like the design challenge, we are looking specifically on base and for the 4 use cases that we mentioned before. And those are all detailed in the challenge brief.
Yeah, certainly one of the components that we want you to keep in mind is that these are going to be used on base. So they're going to be used in the US and at their locations internationally as well. But there is no requirement for any weapons or any armor. It is purely for a cargo transport system on base. The aspect as well that we'd like to state is that with the V22 Osprey, this is a traditional volume that is used by the US Marines to be able to transport cargo, and this is the parameter that for volume that we are really setting by as well.
So similarly, Germano Pecoraro is wondering, the vehicle can carry maximum of 9 soldiers, so can I load 10 people into that volume?
If it's going to be comfortable and viable, I don't see why not. Just make sure that you've got to take into consideration you want people to be able to sit comfortably. Some of the Marine bases are very large, and you don't want to be sat for a 30-mile drive transporting someone if you are shoulder to shoulder with no space to move. So
yeah, safety, ergonomics, they all matter to the Marines.
Some comfort as well.
So, yeah, and some comfort as well. Daha Mohammed Tayeb is wondering, what are the fundamentals of design for logistics vehicles?
So with regards to the fundamentals, one of the key aspects is that you want to start with the key components. So what is going to be your wheelbase, for argument's sake? You want to be able to know that so that you can then build all of the vehicle around it. The chassis is obviously going to be interlinked with that. Make sure that you really focus on how the chassis is built, because we want that to be strong and light and efficient to then be able to build and all of the subsequent modules on. The linkages is also a critical component. How you're going to install the modules, it's great having a brilliant, like a cool design, but if there's no way of attaching them, that is going to be something that we are going to be reviewing. So certainly make sure you have the key fundamentals and the interlocking mechanisms really honed in and designed for manufacturing and for applicable use as well.
Great. So Alex is asking, if I need help finding teammates, can the co-pilots help with that? So Chris, you were a co-pilot.
Yeah, so with regards to the previous competition, a lot of people are very passionate about entering these competitions, and there was a lot of conversation and communication between the actual community on each of their designs, and a very supportive community to be watching in this competition. We can certainly point out different people that might be of benefit to one another. That is certainly something with being a co-pilot on this following stage, that if I find people that are in need and have the necessary skill sets to support one another, I'd be more than happy to point you in the right direction.
Awesome. And just make sure as you're posting comments and you're posting on the discussion threads as you're looking for teammates, just use that @ symbol and then the handle for the individual. And that way they'll receive a notification that they've been mentioned in a comment. So they know, oh, hey, someone is talking about me. Only good things, please.
Yes, very important.
So Alan is asking, does the refined challenge have to use the 6-wheel design, like the 2 winning designs from the first challenge?
No, not at all. It was just a case of that the judges found these to be very impressive. But as you can see from the 5 subsequent judges' preferences, they all had varying between 4 and 6 wheels. It was just a case of that those designs were impressive for the modularity aspect of them more so than the 6-wheel base aspect.
Exactly. So use them as your inspiration, but move forward as needed. Just remember that we're asking a lot from you in this challenge, and it's a relatively short period of time. So the concept challenge was really intended to develop those concepts, and now we're moving into the full-fledged design and engineering. Brenton is asking, are there CAD assets that we can get from OEMs or other partners to help? So one of the things that you can do on our website, we have access just for Launch Forth community members to Siemens Solid Edge. So that's a resource that you can find on the Launch Forth webpage. In addition, there's other available resources under the ignition kit, so you can look there.
Yeah. With regards to any third-party components that you want to use with regards to the CAD, please feel free. We don't want you to be redefining the drivetrain or the suspension mechanism. If you want to pull them off GrabCAD or any other location, there's multiple different open communities out there that allow you to pull in third-party components. That's completely acceptable too. McMaster, if you want your nuts and bolts, they pretty much have the whole world CAD'd up, so you can rely on those to build. As I say, we don't want you to be wasting time redesigning something that already exists, especially with suspension and wishbones, etc. They can take a lot of time, and it's not time that we have. So
yeah, exactly. Another thing is that if you have a CAD design that you've generated and you want to share it, go for it. You can submit an early entry and upload that file, and then just put a call out in the description of your entry saying, hey, I've got these CAD files that I've uploaded, anyone can use them. So, feel free to make that available to the community. So just as a reminder, we're doing live Q&A right now. So if you do have questions, just post them in the comment section for this broadcast. Another question that came in is, the Marines will likely use vehicles off base as well. So should we still account for armor or light weapons?
For this case, no. It's a case of that the US Marines have plenty of vehicles to operate off base. This one is purely to transport wood, mechanical components, and personnel around base. As you may see from the previous challenge, it's located in 29 Palms in California. Is one of the primary locations that we've been working, and we don't see any problems being there. So
awesome. Another question is, what types of parts are great for 3D printing, designed for 3D printing, examples of specific things that tend to break, or how big can we 3D print? So before Chris answers, I'm just going to say the world is your oyster here. 3D printers have come a long way. Additive manufacturing has come a long way. We've seen things printed such as the Strati, which was an entire car. People have printed, now Oak Ridge National Lab is printing submarines. People are printing houses. So don't feel constrained in that regard. One of the examples that Chris showed was casting that was made from a 3D printed mold. In the case of 3D printed sand casting, where they 3D print the sand and then you use a traditional casting method, the typical build size for that is on the order of 1 meter by 1 meter by 1 meter, but those molds can be combined. So you can print and then print a couple of molds and then put them together.
Yeah. With regards to, as Megan stated, 3D printing, we have essentially no limits. The aspect that we can do is that if the parts are too big for traditional printers, we can build in custom scenes that can then be glued together, and they can then have the same structural integrity as a piece that was printed completely as one component. We do have availability to printers here that have the print volume of 16 cubic feet. So we have quite a large range of ability with regards to that. We do have a multitude of different materials as well. So we can print in carbon filled nylon, we can print in ABS, we can print in rubbers. We have got a full spectrum of different materials that we can apply to. So even if it would be an untraditional component that you was thinking of, we have certainly got material access to do a lot of those. For argument's sake, another component that we built recently was a Ultem built exhaust for a NASCAR for testing, and so that was actually ran on a vehicle, and that can be operated completely fine, and that was 3D printed as well. So temperature for vehicle or engine operations is also viable for us as well, just not the engine block.
Although with that said, we are we know the Marine Corps is very interested in large scale metal additives. So those are the capabilities that Fathom has. But again, let your imagination run wild. If you want to print in, you know, whatever is currently available, including metals, go for it. So we have a number of other questions that are coming in, but I know some folks joined late. So we're going to go through the winners of the design challenge one more time quickly, and then we'll come back to answering your questions. So just as a reminder, while we're going through this, as questions come up, just post them in the comment section of this broadcast. So let's navigate back to the beginning. So the first place winner is the Slog by Vasilados Yanis.
Yeah. Yes, this is truly an impressive component. As we said before, you don't have to have 6 wheels. We just thought this was a very impressive modular design. Primarily, so tracking back to one of the previous questions, the modules are all set up with a single axle, so they can be, in our understanding, it could be like essentially wheeled away, and then the second module attached. It doesn't require you to be having to do any heavy lifting, so it just makes it that much easier to do. So that's really a desirable component with regards to this system, and the fact that it has the linkaging in between each of the trailers, so you can cover complex terrain and make it very easy to maneuver.
Awesome. Second place is the Voynich by Gabi Hantig.
So this one, again, follows the 6-wheel principle, just for weight distribution again. But with this, they have the modules being easily liftable and sub 100 pounds, according to their quotes or their statements. So it allows them to be able to have like an like a highly modular truck bed, so to speak, on the aft component. So you can see in the background, we can have it capable for carrying motors, carrying mechanical aspects, woods, all of the different aspects, and it has an internal area for the personnel, so if it's raining or if there's any adverse weather conditions, they can sit inside and be protected.
That's great. And as we mentioned before, Gabi really used every square inch of space in this design, which is awesome. So now for the judges' favorites. The first one that we'll talk about is the Ugly Mule by Brett.
Now, the Ugly Mule, we found this one really desirable because of the functionality that he'd gone through and thought out, like looking at the linkages, how are they all going to be connected? How can the modules be interchanged? this was something that was really a driving factor for this vehicle. A lot of thought went into how all of the different systems can be interconnected, and that was a real highlight for this one and for the competition, because that was one of the key driving factors in the concept stage, was how it was all going to work together.
Yeah. And again, one thing that I just really love about this submission is that Brett took the time to give us the narrative of how he made the revisions and the feedback from the community that inspired those revisions. So we have a very robust digital thread of that co-creation process. So one thing that is, if you look under the timeline on the challenge page, you'll see a blog post that's about the digital thread and direct digital manufacturing and braces, just as a teaser. So that tells you a little bit about the digital thread that we're building out in addition to these challenges. So we're using your submissions to build a digital thread for the Marine Corps, so that as they move forward and look to manufacture this vehicle, if they ever need to change the design, they're able to go back to the very, very first concept that you all are submitting and get a better understanding of why you designed it that way, so that as they're moving forward, they don't have to make the same mistakes over again. The next favorite by the judges is Packhorse 3D, submitted by Christian F.
Now, the desirable component with this, or what got us very excited at launch forth, was the 3D printed chassis that they had designed. They got into the aspects of looking at how to print it on its side, so that we could minimize the amount of material that was going to be employed to actually build it. It was going to be of a very strong and rigid structure using a cellular design, which upon everything else could be bolted and attached to. So it then reduced the requirements to do welding, any sheet metal work. It could just be printed and everything else could be bolted on. Really nice, clean, efficient, and it again used the maximum volume of the predefined area.
Yeah, and those examples that Chris just gave are great justifications for why a part should be additively manufactured. So not everything should be additively manufactured, and in many cases it depends on your design. So if your chassis is something that you're trying to make ultra lightweight and you want that generative design, if it's something that is part of your modularity, so it's something you want the Marines to be able to change out on the fly, then it makes a lot of sense to print it on base. The next one is the LEMV that was submitted by Tom Sazonov.
So this vehicle uses an electric drivetrain again to be able to maneuver the vehicle. It uses, because of the drivetrain being electrical, it minimizes the amount of volume that is consumed by the system, allowing you to have this mono hull that everything else can be bolted to. The driving factor that we found was very inspiring with this vehicle was the actual tubular roll cage design that was mounted to the tub, allowing you to be able to do these like series of adjustments and modifications. So depending on what kind of cargo or personnel that you was carrying, you could then easily manipulate it and change the orientation, angles, lengths of the beams and poles accordingly, so that you could then really refine it and dial it in for what exactly you needed.
Awesome. The next design is the Universal Basic Vehicle, submitted by Brennan Metcalf.
So this one took inspiration from the 1940s Land Rovers. Were very inspirational for the fact that with all of the flat surfaces, you could be able to store a lot of cargo and equipment. Having the flat surfaces allows you to be able to do work and anything that you need on the actual hood of the car. You can check a map, you can work on your laptop, store your coffee, you can do anything you want. But with that, with it all being with flat sheet metal, it makes it very easy to transport all the spare parts. They can be very easily stacked versus those more complex geometries that you see on more traditional vehicles. So very good, very well thought out use of space and how to transport those larger, bigger, bulkier options.
And one thing that Chris just said reminded me, when we were developing the use cases and we were developing the requirements for this challenge, we actually went to 29 Palms, to the Marine base there, to learn directly from the Marines, what are you looking for, what's your current solution, and why is it inadequate? And one of the things that they said is there's not enough cup holders, so you can never have enough places to put your coffee or your drinks. I mean, these folks are out in the desert. These men and women are thirsty, so they need places to put their drinks and their water. The other thing that I love about the two designs that we just went over is, again, they use a very simple structure for snapping together. So it's like the super, the dumbest unit for the integrated circuit. Just make it as simple as possible. And from that, you can build incredibly complex geometries. So I really like that. And the last one that we'll go over is the Modus Mlv, which was submitted by Lulu.
Now, this vehicle, again, used every cubic inch of possible volume available to them. It was an unmanned vehicle design, so it was a case of that there was no drivetrain or steering aspect. So it's essentially removed that use of space so it could then be maximized as best as possible to carry any of the necessary cargo. The office unit, the wood or the mechanical unit could all be stored within there, and every inch was possibly was optimized and used. One of the cool things with regards to this as well is that it does have an electric drivetrain, so it was all underneath the bed of the vehicle, and then had a cylindrical chassis upon which all of the tubular the hoop structure was then mounted on top of. So it was then lightweight, and all of it was very compact and very concise. We found that very impressive.
That's great. So again, congratulations to the winners here. And as we move forward with the MLV Refine Challenge, we're really looking for strong design and engineering so that we can move directly into rapid prototyping. So now we're going to transition back to answering your questions. Again, if you have questions that come up, just submit them in the comment section of the live feed for this broadcast. So going back to what we were just talking about, the last submission that was a judge's favorite used an electric drivetrain. And we've got a lot of questions about what drivetrain should we be using? Should we be using diesel or JP8, which is the common fuel found on marine bases, or should we use electric?
Now, with regards to this, the Marines have stated that they are completely open to go either with a traditional diesel or the JP8 fuel systems for the drivetrains. For their engines, or they are open to going towards electric. It is purely down to your design that allows us to inspire the Marines for each of these options. So it's completely up to you on that aspect. If you want to go hybrid, if you want to do longer range that the batteries potentially couldn't sustain, you can also do that as well.
Yeah, each drivetrain has its own benefit, so it's really up to you, as Chris said, in terms of which one you want to use. Just remember that it's not if it fails, it's when it fails. And the Marines need to be able to move forward when whatever part of this vehicle fails, be it the drivetrain or anything else. So how can you make it as robust and hackable as possible? So that includes the drivetrain. Yeah. Another question that's come in is, could you describe a typical day for each module in terms of the number of stops and the maintenance for the vehicle itself? So a lot of that information is contained in the challenge brief. So you'll see each of the use cases, and you'll see descriptions of the number of people, the type of equipment that they're carrying, and we get pretty specific. So for example, in the administration vehicle, you'll see for the administration use case, they need to carry a scanner, they need to carry a label printer. So we get pretty specific. And for each of those pieces of equipment that they need to carry for the use case, you'll find dummy CAD files for those in the ignition kit. So you can have an idea of just how large these pieces of equipment are. Awesome. Great. Well, it looks like we're finished with the questions on the Facebook feed, but again, as questions come up, you can post them to the discussion threads or under each of the submissions. As you have questions, just tag the co-pilots or folks like Chris, like myself, Austin, Alan, etc. There's a number of us that are trolling the website, looking for your questions and looking for ways that we can support you as you get your submissions ready to go. So in conclusion, we just want to say thank you again. Huge congratulations to the winners. Everyone was really thrilled by the designs that came in. The Marines were incredibly impressed by the breadth of ideas and the complexity and depth of each of those ideas. Yeah,
there was, with regards all of the submissions, I don't want any of you to feel disheartened if you didn't win. There was so many good options and so many good designs. That I understand the judges had a great discussion on which ones were the best, and it was down to the wire, so to speak, on all of them. So they were a fantastic job. Well done to everyone who submitted an application or a design. It was really incredible to see how innovative and how many new concepts and designs came through from this. So really good job, well done.
That's awesome. So as you're getting ready for the MLV Refine Challenge, just make sure that you read the brief and the challenge requirements carefully. A lot of it is carried over from the last challenge, the design challenge, but you'll see a few new things, such as the new design principle for Future Forward, where we're asking you to help us figure out which parts should be additively manufactured of your design. We're using the same use cases, but there's a whole lot more robustness to the ignition kit this time. So really hope that you get to use those. And we cannot encourage you enough to start a team. This is going to be a very technical challenge. As Chris has mentioned, as soon as the winners are announced, we really want to hit the ground running with prototyping your vehicle. So as detailed as you can make those CAD files, as much as you can engineer them out so that they're drivable and they're functional, is really helpful. So it's going to require a team. Oh, sorry, go ahead.
No, I was going to say, even here at Fathom, we have a design and engineering department, and it's a case of that when we work on any project, no matter how big or how small, we always work in teams. We have industrial designers, we have engineers, we have product managers, that we all come together so that we can make sure that a product goes from a concept to reality as quickly and as efficiently as possible. We are working in a 4-week time period with a 2-week review. For the scale of this project, I don't think professional engineers that can commit 100 hours a week would be able to fulfill it in the time frame. So you really need to partner up, as that is going to be the only viable way to actually get a really good refined design in for that submission. So think about that.
Yeah, awesome. And just as a reminder, 2 steps that you can take right now to form a team. So the first is to post what are the skills that either you have that you're offering to the community, or the skills that you need for your team. So you can go to the Discuss tab and look for the discussion thread that's titled Teams, and you can post there and have conversations, find folks that might want to work with you. The second thing that you can do is submit an early entry. When you do this and you're filling out the form, there will be a place for you to call out specific team members that are present on the platform. When you do that, it's going to unlock a private discussion thread where you can share your contact information, take the conversation offline, and just generally organize in private. So feel free to use both of those features as you're starting to form your team. And rest assured that the Launch Forth team is working very, very hard on building out more teaming capabilities on this website, because they're going to be critical to co-creation, which again, that's the lifeblood of our platform, is you all and how you work together. So just a reminder, to catch future broadcasts like this, just make sure to like the Launch Forth Facebook page. And we want to say thank you again to all of you, the Launch Forth community. You've made an incredibly successful and rich design challenge, and good luck to you on the MLV Refine Challenge. We're looking forward to your submissions.
Good luck.